Hello. Hello. Oh, I say. In fact, the network situation today is very terrible. So you have to sympathize with me, okay? Okay. But can you hear me now?
Yes,
Yes.
please.
Okay. So we're looking at image formation in spherical mirrors or formation of images in, let's start with concave mirrors. In fact, there are rules of the game. We have rules. So you first draw your concave mirror. Okay. Now indicate the pole. This is the pole P. Indicates the principal focus. But here, you have to take measurement. Please, are you there? Are you there? Hello, are you there? I hope you can hear me. Or the network is going. Hello. Hello. Okay, so you have to take measurement. Now, I earlier told you that R is equal to 2 times F. R is equal to 2 times F. So all measurements are also taken from the pole. All measurements are taken from the pole. So if I'm taking a focal length of, let's say, 5 centimeters, I have to measure 5 centimeters from the pole.
Please, it's breaking.
It's breaking. Yes, as I told you, today the network situation is so bad. Yes, simply so bad. I try to do everything within my strength, but it's still breaking. And then sometimes disconnecting regularly. But can we manage now? Can we manage? Hello? Irene?
Yes,
Can you hear?
please.
Saddam, can you hear me out?
Deja.
Can you hear me out? If we can manage, then we could do something. If we cannot manage, then we have to, end the lesson. Can we go on? Home. I agree. So, hello, Kezia. Come again.
Yeah.
No, but after some time, then to start breaking. That's what happened first.
That's the problem. But can we continue? Okay, so you have to, if you want to take a measurement of 5 centimeters or 10 for the focal length. So you take measurements. Okay, measure from the pole a distance of 10 centimeters. And that will be where the focal point F would be. Now, because the radius of curvature is 2 times the focal length. If this is 10 centimeter, this must be 20. So R is equal to 20 centimeters. So you have to also measure. So if this is 10, hold on. No, I took 15. Let me take, I think I measured 15 instead. So let me measure 10 as indicated. So this is up. Meaning from the pole to the center of curvature must be 20. So 20 is here. Or once this is 10, you measure 10 from here, and this will be S, center of curvature C. So we have F and then C. These two measurements, very, very important because of this relationship. Please, are we okay? Are we fine? Now, the first rule. The first rule of the game is this. Rule 1. Parallel, don't forget we spoke about paraxial rays. All parallel rays after reflection would have to pass through or passes through the principal focus. So the first rule is that any ray which is parallel to the principal axis after reflection will have to go through the principal focus or the focal point. So this is rule 1. Sanam, Adwa, and Co, are you okay? Rule 2. All rays passing through the focal point or the principal focus after reflection must be parallel to the principal axis. The rule 2 is the reverse of rule 1, and this is what we are saying. Your P is here, the pole is here, focal point F, this is it. The same measurement, so this will be C. If the ray from whichever source, wherever the object is positioned, passes through, or is passes through the principal focus. After reflection, the ray has to go parallel to the principal axis. The ray has to be parallel to the principal axis after reflection. And this is rule 2. Hello, are you okay? Give me feedback to know whether you are there or not. Are you fine? Irene, Sanam, are you there?
Yes, please.
Okay. So this is rule 2. Then rule 3. Let me put 3 and 4 on this. Rule 3. All rays that are hitting or that hit the mirror at 90 degrees. All rays hitting the mirror at 90 degrees after reflection must pass through the center of curvature. Meaning that so long as the ray, let me use this end rather, hits the mirror at 90 normally, this is C. So long as the ray hits the mirror at 90, its reflection must also go through the same path and then pass through the center of curvature C. So the incident, the reflection take the same path, and this is rule 3. Are we fine? Let me bring rule 4 on this. The fourth and the last rule, rule 4 of image formation is that a ray hitting the mirror or incidenting the mirror at the pole P reflects at the same axis, or what we say is symmetrical, or hit it at the same symmetry. This is what we are saying. Any ray coming from whichever source, wherever the object is, and hits the pole of the mirror, would reflect at the same axis. And this is what we mean by the, okay, I will, Adwa. And that's what I mean by the axis. If the ray hits the pole at an angle of, let's say, 30 degrees, then its reflection must be symmetrical to the angle of incidence. It must also reflect at the same angle of 30 degrees. So if this is theta, this must also be theta. And that is the fourth rule. So these are the rules of the game. Irene, Sanam, those of you can see and hear. Are you okay?
Mr. Edia, please can you explain it again?
Come
Then
again.
please, can you send a picture to the group?
I will.
Please, rule 3 again.
All right, I'll go through it again. Let me take the picture first thing. Okay, picture is sent to the group. Now I'm going through once more, so pay attention, okay? So the first rule is that the first rule for formation of images in concave and convex generally is that parallel rays after reflection passes through the principal focus. So all that I'm saying here is that so long as the ray is parallel to the principal axis, after reflection, the reflected ray would have to pass through the principal focus. So, rule 1. This is a ray of light which is parallel to the principal axis. So once the ray hits the mirror, its reflection would have to pass through the principal focus. But this is on condition that you've taken this keen measurement, that the radius of curvature is 2 times the principal focal length. If you don't take into consideration this measurement, it will not work. Please, are you okay? Then rule 2. The second rule is the inverse of the first rule. The first rule, the ray has to be parallel and its reflection has to go through the principal focus. The second rule, the ray has to pass through the principal focus, and after hitting the mirror, its reflected part must be parallel to the principal axis. And so this becomes rule 2. I can actually combine rule 1 and 2 because yes, they are reversible. Please, are you okay? Are you fine? Then the third rule, all rays hitting the line is breaking. That's what the breaking line there. That's what it is, so painfully. Rule 3. All rays hitting the mirror at 90 degrees after reflection must pass through the center of curvature of the mirror. So long as the ray hits the mirror at 90, once it hits the mirror at 90, then it means the incident ray will pass through a point on the principal axis, which we are calling as the center of curvature. Okay, but once this condition is met, the reflection would also take the same path. So the same part of the ray as the incident, and then the same part of the ray as a reflected ray. Okay, and this is on condition that the ray hits the mirror at 90 degrees. Are we fine? Sana Menko, are you fine? Then the fourth rule. The fourth rule is that a ray hitting the mirror at the pole reflects at the same axis or at the same symmetry. Reflect at the same axis or symmetry. And this is it. It's the illustration. Once the incident. Hello. 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 Zanam, Kezia, Gloria, Irene, Sally,
Hello.
can you hear?
Yes, please.
Yes, please.
It's a burden down
The
here.
board is
The board is blurry.
yeah.
From frying pan to fire. So the fourth rule is that once the ray hits the mirror at the pole or at the center, it will also reflect at the same symmetry. So when the ray hits the pole at maybe 30 degrees, it will reflect at 30 degrees. If it hits the pole at an angle of 45 between the principal axis and then the incident ray, it will also reflect at the same symmetry. So these are the rules that I use for the image formation. Please, are you fine? Are you okay?
No, please.
Like if you have a problem, let me know which one. Okay, which exact rule, so I explain.
Please, the rule 3.
Okay, so let's pick. Let me clear this and then take you through the rule 3. So there's the mirror. Let me change the marker. So there's the mirror, and it's concave. Before, identified the pole, the focal length, then the center of curvature. But I said this has to be done by measurement. R is equal to 2F, a very important relation connecting radius of curvature to focal length. Please, are you fine? Okay. Then rule 3. The rule is saying that whenever you have a ray from the object or from whichever end, and the ray is hitting the mirror at 90, so long as the ray hits the mirror at 90, it will reflect along the same path taken by the incident ray. Are you with me? Hello, are you with me? Good. So the reflected path will take the same path or direction as the incident. So this is the incident, this is the reflection. And it will pass through a point on the center of our principal axis, which we call as the center of curvature C. And this will happen so long as the ray hits the mirror at 90. So if it's from the other end, so long as the ray hits the mirror at 90, this is what will happen. So all the rays will pass through a point which we call as the center of curvature. So this is the third rule. Are you fine? So it can be any of these rays, but I just double it to let you know from whichever angle the rays are coming from or is coming from. Once it hits the mirror at 90, this is what will happen. All is well. Please, if you have any other concern, let me know before we move on to anything else. Is that okay?
Yeah.
Hello, I'm here.
Mr. Dear, please,
Yep.
can you go over the rule 4?
Okay. Rule 4. The fourth rule says that the ray has to hit the pole of the mirror.
Mr. Dear, please, shall I keep some breaking? I can't hear anything.
Irene, I can hear you. Irene, it shall be well, okay? So the fourth rule is this. My focal point intact. Center of curvature is twice the focal length. So C. Now all that we are saying is that if the ray from whichever source, wherever the object is, when the ray hits the pole P, it has to reflect at the same symmetry. What do we mean by the symmetry? Assuming this angle is theta or 30, then the reflected ray, the angle between the reflected ray and then the principal axis must be the same. So if this is the reflection, if this is 30, this will also be 30. And that is what we mean by symmetry. So this is the fourth rule. Whoever asks for explanation, are you fine?
Yes, please. Thank you very much.
Welcome. So let's try to go through the first image formation and see how we can use the rule. Now, you are free to use any of the rules so long as it is applicable or so long as it can be used. What I mean is that some of the rules cannot be used depending on the position of the object. So, one, let's look at describe the nature of image formed when objects is one or I. You are to describe the nature of the image form when object is one between, okay, placed at the center of curvature. II. Between the pole and the principal focus. So we are giving ourselves two situations. We are to describe the nature of the image formed for concave. This is for concave mirror. So all the consideration is on concave mirrors, okay? All right, so let's look at how we can handle this challenge. So the first thing to do is to have your mirror. The mirror usually would have a small aperture. You rule a line behind the mirror to cater for reflections which goes beyond the aperture of the mirror. And so we have this straight line behind the mirror. All that I'm saying is that you can't draw a very big mirror. Practically, the mirrors we use in the lab just have a very small aperture. So you just draw a line behind, and that would cater for reflections which go beyond the aperture of the mirror. Please, are we fine? This is the principal axis. Sanam, Adwa, and Ko, are you there?
Yes, please.
Okay. So this is the principal axis. Take your measurement because we are using R is equal to 2F. Very, very important. If you don't apply this, everything will be wrong. So let's first determine the focal point. Let's just guess a distance for your focal point, maybe 10 centimeters. So we are measuring 10 centimeters from the pole. So that's on 20, so 10 centimeter will be here. Meaning from the focal point to the center of curvature 2 must be 10. So I have to extend my principal axis. Good. So if this is 10, then this will also be 10 from here. So take measurement, very, very important. So this is C, this is F. Now, where is the object placed? In the first situation, you are told that when the object is placed at the center of curvature. So the object is exactly here. Not too tall of an object. The object is placed at the center of curvature C. So use ray diagram to describe the nature of image that will be formed. Are you with me? Are you with me? Hello.